Hello everyone, welcome to my YouTube channel. Today we are going through problem on truss elements. This is the problem. Before going to this problem, please subscribe my channel and like and share the link. Okay. Then the problem is solve the problem solving with finite element method. Okay. This is the problem for the two-bar trusses as shown in figure. For two-bar trusses as shown in figure, determine the displacement node and stresses in each element. Okay, what we have to find means displacements and stresses in each element. This is the figure we have to observe. Okay, in this figure there is a two elements, element number 1 and element number 2. These are the two truss elements. Okay, the length of the first truss element is 500 mm and second one is not given in the problem. Okay, then there is a two supports at node 2 and at node 3. Then there is a point load acting at node 1 downward direction. Okay, these are the displacements q1 q2 q1 q2 q3 q4 q5 q6 is the displacements at node 1 node 2 node 3 respectively. Then first of all we have to indicate the element numbers in the figure, then node numbers, after that displacement numbers. But in this problem they given in the question itself. Okay, here in this problem the length of the second element is not given in the problem. We have to find out. Here the horizontal distance is from point 1 node 1 to node 3 400 mm and vertical distance is 300 mm. This is the right angle triangle. You consider from this triangle you find out the length of the second element. The value we got the length of the second element is 500 mm. This is a by the use of Pythagoras theorem you got the length of the second element. Length of second element equal to under root of 300 square plus 400 square equal to 500 mm. Okay, this is the length of the second element. Then what he given means he equals 70 into 70 GPa means gigapascal. 70 into 10 power 9 GPa value is 10 power 9. Pascal means Newton per meter square. Then area is given in the problem is 200 mm square for the both elements, element number 1 element number 2 having the area and length modulus is same. Okay, the first step is to find out the element connectivity table. Here this is the element number, this is the nodes 1 and 2 are the starting and ending nodes of the element. Okay, in this problem we have the two elements, element number 1 and element number 2. That value element numbers is indicated here 1 and 2. Okay, then the nodal numbers we have to find out. First element in this diagram, the first element having the nodal numbers are 2 and 1. This is the direction we consider. Okay, starting node of element number 1 is 2 and ending node is 1. So you have to indicate the starting node is 2, ending node is 1. Okay, then element number 2 from the figure, element number 2 having the node numbers 1 and 3. Starting node is 1, ending node is 3. Okay, this is the direction. Starting node is 1, ending node is 3. So you have to indicate the starting node is 1, ending node is 3. Okay, then nodal point table. In nodal point table you have to indicate the x and y coordinates of the each node. Okay, from the figure only you have to take in these values. You have to indicate the x and y coordinates of the each node. Okay, here this is the origin. You consider this is the origin. Here the value x comma y is 0 comma 0. Okay, at second node the coordinates x distance is 500. This is the left side, so you have to keep minus 500 comma along y is 0, minus 500 comma 0. Here the length along x-axis is 400 comma vertical axis it is downward direction, so minus 300. Okay, at node 1 there is x equals 0, y equals 0. So x equals 0, y equals 0 at node 1. Similarly, node 2 minus 500 comma 0. So minus 500. Similarly, at node 3 400 comma minus 300. Okay, this is the nodal point table. Based on this table, you have to calculate the c value and s value. This is the direction cosine table. Okay, here element number 1 and 2, element number c is the x2 means x1 by l, and y is the s is the y2 means y1 by l. Here l means length of element. Okay, here the first element having the node numbers 2 and 3. Okay, 2 is the starting number, 1 is the ending number. 2 and 3, this is the x1, this is the x2. X2 means x1 means 0 minus of minus 500 means 500 by length of first element is 500. 500 by 500 means 1. Okay, similarly y2 means y1, 0 means 0, 0 means 0 by anything is 0. Okay, same. Next, second element having the nodal number starting is 1, ending is 3. So starting is the x1, this is the x2, this is y1, this is y2. So x2 400 minus 0 means 400 divided by length of second element is also 500, so the value is 0.8. Similarly, y2 minus y1 means minus 300 divided by length of element is 500 means 0. Minus 0.6. The next step is to find the element stiffness matrix. This is the formula for the truss element stiffness matrix. A equal to AE by L C square CS minus C square minus CS CS S square minus CS minus S square minus C square minus CS C square CS minus CS S square, sorry, minus S square CS and S square. This is the formula for the stiffness matrix of the truss element. Okay, for the first element k1, the in Young's modulus value is 270 into 10 power 9, and the area is 200 mm square, that converted into meter square by multiplying with the 10 power minus 6. Then this is the length of the element, first element 500 mm, that is converted into meter by multiplying with 10 power minus 3. The c values are just we find out that values, you have to submit that values in this matrix. You got this matrix. Okay, then this is and you calculate this value, you got the value of 0.28 into 10 power 8. 10 power 8 keep outside, the 0.28 multiplied with this matrix, you got this matrix form. Okay, here this is a k1 matrix, first element matrix. This is the first element having the nodal numbers 2 and 1, starting is 2, ending is 1. At 2 there is a displacement 3 and 4, and at 1 there is a displacement of 1 and 2. So you have to keep this starting is this and ending point is 1. So 3 4 1 2, you have to indicate the 3 4 1 2 and to the top and right side of the matrix. So here the displacement numbers 3 4 1 2 and 3 4 1 2, you have to indicate top and right side of the K matrix. Then to convert this matrix into homogeneous matrix, you keep first of all you keep 10 power 8 is common outside, then open the bracket. The total number of displacements in the figure is 6, so you have to keep the all 6 numbers on top and right side of the matrix. Then in this matrix there is 5 and 6 nodal numbers, there is only 3 4 1 2, there is no 5 and 6. So you have to keep fifth column, fifth row, fifth column, sixth column, as well as fifth row, sixth row as zeros. Okay, the remaining place, whatever it may be remaining left here, that places is refilled with this matrix. Okay, this is a K matrix, element stiffness matrix for the first element. Similarly, then the form to find the second element stiffness matrix, using the same formula, substitute this second element values of C and S. You got this, like this is the C value for the second element, this is the S value for the second element. This value is given in the question, and length of element we got 500. The second element also 500 mm. So converted into meters by multiplying 10 power minus 6. Then the value you got here means the value of this entire thing is 0.28 into 10 power 8. The 10 power 8 keep outside. That 0.28 is multiplied with this matrix. You got this form. Okay, this is the K matrix second element. Second element having the nodal numbers 1 and 3. 1 and 3 having the displacements 1 2 5 6. Okay, 1 and 3 having the displacements 1 2 at node 1, 5 6 at node 3. Okay, so you have to keep the 1 2 5 6 at top and right side. To convert this matrix into homogeneous matrix, first of all you have to keep k to equal 10 power 8 outside, open the matrix, then keep all the displacements at top and right side. Okay, here there is, in this matrix there is no 3 and 4 displacements, so you have to keep third column, fourth column as well as third row, fourth row as zeros, and remaining places are filled with this matrix. Here this is a 1 1 1 first column first row 1 1. Where is the 1 1? Here this is a 1 1, 0.179. You have to keep it this. Okay, similarly 2 1, 2 1 is minus 0.134, 2 1 is minus 0.134. Similarly keep all these values in this matrix at respective position, with respect to position. Okay, after finding out the global after finding the shiftness matrix of the first element and second element, you have to find out the global shiftness matrix. Here global shiftness matrix is k equal to k1 plus k2. This is a k1 matrix you got, and this is a k2 matrix. Okay, both matrices having the 10 power 8 as a common, so you have to keep outside. Then add this 0.28 plus 0.17, you got 0.45. Next 0 plus minus 0 minus 0.13 means minus 0.13. Similarly minus 0.28 plus 0 means minus 0.28. Similarly you have to add the all these two matrices. You got this matrix. Okay, this you got this 6 by 6 matrix. This is the global shiftness matrix. After finding out the global shiftness matrix, you have to find out the global load vector. Here global load vector F equals sigma Fe plus sigma Te plus sigma Pi. Sigma Fe means body force, sigma Te means tractive force, sigma Pi means point loads. Okay, there is in this problem they do not give any body force or tractive force, so you have to keep this two values are 0. Then point load, from the figure you have to observe the point loads where it is acting. Okay, here at node 1 there is a 2, there is a 2 displacements q1 and q2. Here along q1 direction there is no load, along q2 direction there is a point load of 12 kilonewton, but it is in the downward direction, so you have to keep this is a negative value, taking this is a negative value. Then at node 2 there is no loads, you have to keep all the, q3 and q4 is 0. Similarly node 3 as also there is no load, so you have to keep here also 0 and 0. At q1 q2 q3 q4 q5 q6, this is the at node 1 there is no load along the q1 direction, so you have to keep 0. At node and at node 1 along q2 direction there is a node of 12 kilonewton in downward direction, so you have to keep negative sign. Remaining nodes there is no load, so you have to keep all are 0. Then from the Rayleigh-Rich method, kq equal to f. This is a k matrix you got. Then q1 to 6 you have to written, and f matrix just we got, that is written is after the is equal to, okay, equal after the equal. Next by using the elimination approach, first of all we have to at suppose there is no displacement, so we have to observe the where the supports are there in the figure. So in this figure the supports are there at node 2 and node 3. At node and node 3 there is a displacement q3 q4 q5 q6, so displacement is 0, so you have to keep all are equal to 0. So eliminate this corresponding rows and column q1 q3 q4 q5 q6. Eliminate this corresponding row and column. Here this is a q3, we have to cancel. Next q4, next q5, next q6. Okay, similarly rows also q3 Q4, Q5, Q6. After eliminating this corresponding rows and columns, the remaining value is 0.5 minus 0.13 minus 0.13 0.10. Similarly, Q1, Q2 and 0 minus 12 into 10 cube. Okay, so you have to written this remaining matrices here. Okay, then this 10 power 8 is keep out after that equal, then it will convert it into 10 power minus 8. This is the matrices. You have to multiply these two matrices. You got an equation of 0.45 into q1 minus 0.13 into q2 equal 0. Next, minus 0.13 into q1 plus 0.10 into q2 equal minus 12 into 10 power 3 into 10 power minus 8. These are the equations you got from the above matrices. These are two equations you got from the above matrices. Using this, solve this using the calculator. You got the values of q1 and q2 in terms of meters. Minus 5.55 into 10 power minus 4 is the q1 value, and q2 is the minus 1.92 into 10 power minus 3 is the q2 value. Okay, this is a q matrix. q1, q2, q3, q4, q5, q6. Here q1, q2 values are there. We got the remaining values are 0 because of at supports there is no displacement, so 0. Keep it all is 0. Okay, stresses in each element. Stresses in each element, sigma equal to E by L minus C minus S CS into Q. Here sigma 1 E1 by L1 minus C minus S CS. Here the first element having the nodal numbers 2 and 1, having the displacements of Q3, Q4, Q1, Q2. Okay, then substitute all these values. You will got the value of minus 0.777 into 10 power 8 Newton per meter square. This is the first element stress value. After that, you have to calculate sigma 2. Here the element number 2 having the nodal numbers 1 and 3, having the displacement q1, q2, q4, q6. Substitute all the values. You have already known these all the values, then you will got the value of sigma 2. Okay, whereas to find the reactions at supports there is no displacement, so at supports wherever the supports are there, at that place only the reactions are came. Since q3, q4, q5, q6 is 0, okay, the remaining rows in the k matrix is eliminated, so the r equal to kq minus f. This is the reaction formula. The remaining rows are here written. Okay, this is the matrix k matrix. After eliminating the 1 and 2 row, first and second row, the remaining rows 3 4 5 6 3 4 5 6 rows, this is the matrix of k, and this is the q matrix. Q matrix you have to keep all the values q1, q2, q3, q4, q5, q6. Okay, then f matrix. F matrix you have to keep 2 3 3 4 5 6. Okay, then multiplying with these two, you got the. Okay, after submitting the values of q displacements, this matrix will form in this okay, in this format. Then multiply with these two matrices, you will got an value. You will got this matrices. Okay, multiplying with 10 power 8 with this matrix, you will got the r3, r4, r5, r6. Okay, this is the reactions. Okay guys, thank you for watching. This is a second problem of truss elements. I have already posted in the first model of the truss elements. Okay, uh, if any doubts or queries, please post in chat box. Guys, please subscribe my channel, share the link and like my video. Thank you for watching.